Hello everyone! I've just got the Burroughs 3D printer kit for Voron Trident. Burroughs sent me this kit for a review. I'm really happy because it gives me valuable content for my channel to share with you, and also because this was the next printer I wanted to build. So in this video I will unbox the kit and then I'll make a second video for the assembly and tests. So if you want me to focus on a particular build process, please drop a comment below. So what is Voron Trident? It's a do-it-yourself Core XY 3D printer designed by Voron Design. And it's successor of their Voron 1.8 printer, very robust machine. It introduces great new feature, which is the 3-point bed leveling. That's why the bed is now moving on 3 linear rails with 3 independent motors. The printer is enclosed like all other Voron machines. The print head is on a larger MGN12 linear rail. All other linear rails are MGN09. The skirts and the display holder have been redesigned. On the Voron website you will find links to the manual, STL files for 3D printed parts, and a configurator and sourcing guide. You can source the hardware yourself or buy a kit, which saves a lot of time. Burroughs is a high quality kit builder. They sell on AliExpress. I've already built a 3D printer with one of their kits. It's the Voron 0.1 and I'm very happy with it. They package quality components like high wind linear rails, LDO motors, then you have a choice of decent hot ends, and normally everything prescribed by Voron should be in this kit, so I'm quite confident that I will build a nice printer with it. Let's unbox it. The kit weight is 20 kilograms. It was sent with DHL and I received it in 5 days. Everything is well packaged and in perfect condition. Here are the 3 steppers for the Z-axis. Those are 42 mm high NEMA 17 motors from LDO with integrated lead screws. They are branded with the Voron logo and are equipped with a normal nut, not an anti-backlash nut. Just like the Voron 2.4, the Trident uses energy chains on all axes. In the kit are supplied 2 meters of good quality openable energy chain with radius 1.8 centimeters. This is more than enough to make the 3 chains, and there is a set of 2 end elements for the third one. Here are the 2020 aluminum extrusions for the frame. They are pre-cut and taped and seem good quality, black anodized and matte. It is cool because personally I don't like glossy bling profiles. Now I see there is a list of all components. It will be easier to go through it and check everything. Here are all the small parts for the build. A Raspberry Pi 4 to run the print server and clipper. In the list it's written they sent random 2 or 4 gigs of RAM Raspberries. Lucky me. 2 gigs is plenty enough though. I think even Raspberry 3 would be okay because this printer runs a single control board. 5 fans are supplied, 3 big 60 by 60 mm for the electronics compartment and for the exhaust filter, 1 40 by 20 blower for part cooling and 1 40 by 10 for the hot end. Here are the Omron inductive probe for ABL, set of cables with JST connectors. I think those are pre-cut for the fans and the instrumentation. A single PTFE wire with DuPont connector, I don't know yet what is it for. Hot end heater, 3 pre-wired end stops, but there's also a Hall effect sensor which is kind of overlapping. This bag contains power cables with fork ends, red and black flexible silicone wires and some JST connectors. The thermistor is supplied with extension cable. In the packing list is actually written that the Hall effect sensor and this carbon filter are random gifts. Nice. The Trident has 6 steppers and there are 6 stepper drivers supplied. They are TMC2209 manufactured by Big3Tech, 2 in a box. The control board supplied by default is Spider, but it is possible to request the Octopus from Big3Tech. I took the Octopus because this way the drivers and the display are from the same company and I'm sure everything is compatible. Here is the display. Nice addition to the army of ducks of my little kid. The hot end by default is the high flow Dragon from Fetus, but you can request also the standard flow one. Here is the solid state relay for the hot bed and a DIN rail adapter. It is from Omron. Power supplies, 5 volts 25 watts for the Raspberry Pi, which is 5 amps, and 24 volts 200 watts for the control board. Both are from Minwell. Do-it-yourself dual drive kit for the direct printhead. In the same bag are the magnets for the enclosure door and the Hall sensor. In the box there's also VHB tape, bearings, set of idlers and pulleys, rubber feet, the power inlet, small cable ties, some Teflon tubes, USB to USB Type-C cable and few other accessories. Here are the spherical bearings for the 3-point bed leveling. They allow to adjust the plane of the bed to the gantry. The belt for the XY motion is from Gates. I found also a 32 GB micro SD card supplied inside the Raspberry Pi box. Let's check the hot bed components. Here is the build plate, PEI coated spring steel sheet and magnetic sticker. The spring steel sheet seems an energetic product. It is textured from both sides. In the components list is written that Burroughs sent randomly textured or flat steel sheets. The build plate looks gorgeous. It is 8 mm thick, fine milled and stress relieved and seems very well machined. Burroughs claim it is MIC6, and I believe it. After the unboxing, I'll make a quick check how flat it is. The silicone heater is unbranded, 600 watts. It seems okay. The thermistor wires are PTFE isolated with additional common silicone isolation. This is the high temperature LDO motors kit for Voron 2 and Voron Trident. They are two big 0.9 degrees NEMA 17 steppers for the A and B drives and a pancake stepper for the direct extruder. All three motors are rated up to 180 degrees Celsius. There are 6 linear rails on this printer, 3 MGN09 for the Z-axis, 2 MGN09 for the Y, and an MGN12 for the X. The rails are high quality, genuine high wind, and this is a huge advantage for this kit. They are supplied without carriage stoppers, so be careful when you take them out from the packaging. They slide great and need to be cleaned with isopropyl alcohol and greased before installation. The screw kit alone weighs at least 2 kilograms. Here you'll find all specified types of screws, hammerhead T-nuts, Rowan T-nuts, washers, plastic threaded inserts, and all of these are in separate labeled bags. The Trident can be fully enclosed. This kit includes 3 mm thick black coroplast and clear acrylic panels, precision cut based on Voron drawings. Finally, there are 2 DIN rails for the electronics compartment. So of course this kit doesn't include any 3D printed parts. You will have to print them yourself or buy them from the Voron community or from AliExpress. Normally the colors of Voron are main color black and then accent color red. But you can choose your own color therapy. I started printing the parts. As you see here, I'll have maybe 2 main colors, 2 accent colors, black and blue as a main color and red and light gray for accent colors. Let's see. So last in this video, I would like to see how flat is the hot bed. I'll do a bed mesh, knowing that Voron requirements are quite tough for the beds. There should be less than 0.1 mm deviation. So I have here the clicky prop. I think the accuracy is set to 0.03 mm. So I think, okay, although not absolutely precise, a bed mesh will give good idea how flat is this plate. I'll just put the plate over the hot bed of my Voron 2.4 and I will do two bed meshes at room temperature and at 100 degrees Celsius. I'll use the Bed Visualizer plugin for the analysis of the results. The printer is performing a quad gantry leveling to align the gantry to the plane of the bed. Then the bed mesh is at 25 points with average of 3 measurements at each point. Here is the result. The maximum deviation is 0.069 millimeters, which is absolutely fine. In reality, it could be even less because the results for the extremities of the bed are extrapolated. Anyway, this plate can be considered flat. Here is the bed mesh at 100 degrees Celsius. I thought the maximum deviation will be higher, but in fact it is the same or less. So that is almost all from me. I honestly think this kit is fine for building Voron Trident. What is in fact different from the Voron specification are the connectors. I didn't find any microfit connectors in the kit, instead they are JST connectors. Anyway, I think most people are using JST because they are more compact and also easier to find. One thing I will change during the build are the wires that go through the energy chains to the print head. I don't know why Voron has specified silicone wires. I thought it was commonly agreed that in the fast-moving chains PTFE isolated wires are better because they are more wear resistant. So here I'll be using PTFE wires, and if you order this kit, order as well something like 20 meters of PTFE wires from AliExpress. They are pretty cheap. What else? Why building a Voron? Look at these parts. Those are 100% infill ABS parts. Normally Voron specifies 40% infill, but I print everything solid. So out of all these parts, I didn't have a single part that failed or that I had to reprint. So these printers are very reliable. And at the end, it saves you some material cost, but also a lot of time. So see you in 2-3 weeks to put all this together in a Voron Trident and test it. Thanks for watching. Bye bye.